roots of quadratic inequalities. Now, standard form of a quadratic inequality would be of the form ax square plus bx plus c. Maybe it's less than 0 or maybe it's greater than 0. Now, solving these would actually mean that we're trying to find x's which solve these inequalities and make these inequalities true. And the solutions will mostly be in the form of intervals, okay? Certain numbers in between an interval would make these inequalities true. So, for example, let's try to understand this example. You have 3x square minus 5x minus 8 is greater than 0. So, this is a quadratic inequality. Now, can I factorize it? Yes, I guess I can. So, we will have plus 3x minus 8x minus 8 strictly greater than 0. That means 3x can be taken common here. So, x plus 1 minus 8 can come out common here. So, x plus 1 is strictly greater than 0. 3x minus 8, x plus 1 is strictly greater than 0. Okay, so we have this inequality now. How do I solve it? Now, to find out the correct x's, what I need to do is, we can use 3 methods to solve actually. There are 3 methods to solve such inequalities. One is using the number line. So just finding out on the number line what numbers would actually make this positive using number line. We can solve it algebraically also. So you have an algebraically. Okay. And thirdly, using graph. So let's see how I do this. Now, a quadratic in general can have how many roots? 0, 1 or 2 roots. Maximum 2 roots, right? So find the 2 roots and based on which we can solve the inequality. So what we will do, we will try to find out the roots of this quadratic that we have, quadratic polynomial equal to 0. So find the root. The first thing, find the root of the quadratic that you have. And based on that, we will try out our number x's which will suit this inequality. So we have 3x minus 8 into x plus 1 is equal to 0. If I try to find out the roots, so the roots would be x equals to 8 by 3, which is approximately 2.6, and x equals to minus 1, right? X equals to minus 1. So if I draw a number line out here, this is say 0, this is minus 1, this is 1, this is 2, and this is 3. So 2.6 would be somewhere here. Now what happens if I have numbers on the right of 2.6? What happens if I have numbers on the right of 2.6, and what happens if I have numbers on the left of it? So let's take on the right of 2.6 is 3. So let's take 3. Okay, let's take 3. Say we have taken 3. Now if I take 3, then 3x minus 8 into x plus 1 becomes 9 minus 8 into 4 so which is equal to 1.4, and this will be greater than 1 into 4, which is greater than 0. 4 is greater than 0, so that means it is satisfying satisfying inequality. Satisfying inequality, right? What happens if I take some other number? Let me take on the left of 2. If I take x equals to 2, left of 2.6 is 2. So if I take 2, then this becomes, let me use red again, then this becomes 6, 3 into 2 is 6 minus 8 into 2 plus 1. So this becomes 2 into 3, minus 2 into 3, sorry. So this is minus 6, which is less than 0. So my inequality is not satisfied. My inequality is not satisfied here. Okay, so it does not satisfy my inequality. What happens on the left of minus 1? On the right of minus 1, we have seen 2. Let me take on the left of minus 1, let's take, on the right of minus 1, let's take minus half. Let's take minus half. Okay, so which will be somewhere here. Let's take minus half, which is somewhere here. So this will become 3 into, it's 3 into minus half minus 8 into minus half plus 1, which will be equal to minus 3 by 2 minus 8 into half. So this will give me, this will equal to minus 19 by 2 into half. So minus 19 by 4, which is negative. So again, does not satisfy the inequality. Does not satisfy. So what we are trying to say here is that if I have a point here, it does not satisfy. If I have a point here, 2 was not satisfying, 3 satisfied. And let me now check something on the left of minus 1. So let us take, say, x equals to minus 2. Minus 2 is on the left. So 3 into minus 2 minus 8 minus 2 plus 1 will give me minus 14 into minus 1, which is 14, which is greater than 0. That means any point on the left of minus 1 will satisfy. So that means what we have checked is that on the left of minus 1 points are satisfying, and on the right of 2.6 the points are satisfying. So my solution set becomes anything that is less than minus 1. Anything that is less than minus 1, either that or else anything which is greater than 2.6. So I have a solution set in form of an interval which is minus infinity to minus 1 union 2.6 to infinity.